We got this really interesting stuff this week all about RARE, Retrieval-Augmented Reasoning Modeling, which, yeah, sounds super complicated, but it's actually a pretty cool way to help doctors figure out, what's making people sick. It's kind of like, think about it like this. Imagine a super smart, like a detective doctor, right? And they have access to every single book in the world about medicine.
Wow, that's a great analogy. That's really getting to the core of what RARE is trying to do.
Yeah, and so this RARE thing helps them find like the exact right book and the exact right page super fast to kind of solve the mystery of what's making people sick.
You've got it. That's the core promise of RARE, making all that complex medical knowledge much easier to use and access so doctors can figure out what's wrong and how to help.
So our job today is to really dive deep into this RARE thing. Like, what is it? How does it actually work? And why is it potentially like a big game changer for helping doctors help us when we're not feeling well? And we're going to try to explain it in a way that anyone can understand, even if you don't know anything about medicine or computers or AI or any of that stuff.
I love that approach. Sometimes the best way to understand something complex is to break it down to the simplest terms.
And one of the things you sent over, this report from that database guy deep dives, it had this really great way to picture this whole RARE thing. I said, imagine that like super smart computer doctor we were just talking about. RARE is like giving that doctor the world's biggest and most up-to-date library filled with nothing but medical books.
Right. And it's not just giving them the library, it's also like teaching them how to be the absolute best at finding exactly what they need in all those books.
Oh, and then thinking really hard about what they find to figure out what's wrong and how to make things better.
Exactly. The power of RARE is that combination. A huge amount of information at their fingertips and then the smarts to use it to figure things out like a real expert.
Okay, so let's dig into that core idea a little bit more. RARE basically is this special trick to make those AI brains, those smart computer programs, even better at solving problems. And in this case, we're talking about medical problems, figuring out what's going on with someone's health.
Yeah, that's right. It's all about helping computers learn and think in a really new and clever way. And it's not just about memorizing a ton of information.
Yeah, because normally you think a computer just remembers everything it's been told.
Yeah.
Right? Like that's what computers are good at, just remembering stuff. But RARE does something different.
You got it. So instead of just using what it's learned before and what's in its own memory, RARE can actually go out and find new information whenever it needs to. It's kind of like it has this superpower to access this huge internet, but the internet is just medical information. That biggest library idea is super helpful here.
So two main things are happening with RARE, right? First, we have all that information stored somewhere, like in those massive medical libraries we're picturing.
Right. Those are called external knowledge sources. You can think of them as just these giant collections of medical research papers, textbooks, all sorts of reliable, up-to-date medical info.
Gotcha. And then the second thing is teaching the computer how to actually use that information to think, like a doctor would, to solve the problem, figure out what's going on with the patient.
Exactly. It's not just about finding the right facts. It's about learning how to use those facts to connect the dots, just like a doctor would, to understand the illness.
So it's less about just remembering like a list of diseases and their symptoms, and more about like learning the skill of how to put all the clues together and figure things out.
Precisely. RARE is all about the process of using information, not just the information itself. The report even mentions something called Bloom's taxonomy. It's basically a way of thinking about different levels of learning. And RARE is all about reaching that deeper level of understanding, not just remembering facts.
Interesting. So how is this better than how computers used to be trained? Because I always thought it was all about just memorizing tons and tons of stuff.
Well, you're right. The older ways of training AI often involved just feeding it tons of data and hoping it would recognize patterns. It was kind of like trying to make a computer read every single book in the library and hoping it would just absorb everything. That took a ton of computer power and sometimes meant the AI was good at repeating what it had seen, but not so good at dealing with anything new or different.
Makes sense. So step one with RARE is finding the right information. How does it do that? It's not like it just randomly opens a book in its giant library, right?
Not at all. Think of it like this. You go to our computer doctor and tell them how you're feeling. You say, my tummy hurts and I feel a little hot. So RARE needs to search through its medical library, those databases, to find info that talks about those things, tummy aches and feeling hot.
Okay, and what kind of books or databases are we talking about here? What's actually in this super library?
Good question. The report gave some good examples. There's general knowledge stuff like Wikipedia, which can be helpful for some background. Then there's something called PubMed, which is basically a giant collection of all the latest medical research papers that scientists write. Then you've got medical textbooks. Those are like the main guidebooks for doctors. And then summaries like Stat Pearls, which are kind of like shorter, easier to read versions of those big textbooks. They even mention something called MedCorp, which sounds like a really specialized collection of medical knowledge.
Wow, so it has a lot of different places it could look for answers. And the report said that sometimes it looks at the top 3 most helpful things it finds. Why just 3?
That's a great question. It's kind of about finding the right balance. You want enough information to make a good decision, but you don't want to overwhelm the system with too much information, right? So 3 is often a good number to start with. Get the most important and relevant info quickly.
Makes sense. So it takes what you tell it, like, my tummy hurts and I feel hot. And it turns that into search questions for the library. How does it know what questions to ask to find the best information in all those books?
That's where the training comes in. RARE is taught how to understand those medical words and how different symptoms and illnesses are connected. It learns to ask the right kinds of questions to its big library to get the most useful answers back. The report also mentions some of the specific tools it uses to search.
Oh, like those vector databases. That sounds a little bit like computer magic to me.
It does sound like magic, but it's pretty cool. Think of it like this. Imagine you're looking for a book about cats, right? A regular search might only find books that have the word cat in the title, but a special search, like the kind RARE uses with these vector databases called FACE and Pinecone, it can understand that kitty or feline are also related to cats, even if those words aren't in the title.
So RARE can find information based on what it means, not just the exact words.
Exactly. It understands the concept behind the words. And it can also use special collections of information that maybe just a specific hospital or a group of doctors might have. And because RARE can always go back to its library and look for the newest information, it can stay up to date with medicine, which, as we know, is constantly changing.
Okay, so it's found the information, it's gone to the library, found some books and pages that seem important. Now what? How does it actually think about that information to figure out what might be wrong with you?
Okay, so once RARE has found the right information, the next step is the thinking part. This is where it gets really interesting. It's like our detective doctor has found some clues in the medical books, and now they need to put those clues together to solve the mystery of your tummy ache and fever.
So it's not just reading the information, it's actually connecting that information to the problem, to your symptoms.
That's it. RARE is trained to understand how all of these different pieces of medical information fit together and how they relate to what you're experiencing. The report mentioned one way it might do this by trying out different ways to get to the answer, kind of like trying different paths in a maze until it finds the way out. They use something called Monte Carlo tree search.
Monte Carlo tree search. That still sounds a bit complicated.
Yeah, it does. But the basic idea is that RARE tries out different possibilities. It's like, okay, maybe it's this. If it's this, then this might happen. It explores different ideas to see which one makes the most sense based on the information it has.
So like a doctor thinking about different possible diagnoses based on what you tell them?
Got it. And the report also said that RARE can actually ask itself little questions and then search for those answers too.
Right. So if RARE gets stuck or needs more information, it can actually ask itself a question like, what usually causes a tummy ache and a fever together? And then it goes back to its library, to those databases, to find the answers. This helps it really understand things in more detail. So it doesn't just stop at the first answer it finds. He keeps asking questions, digging deeper. That's really cool.
Yeah, it's a really smart system. And then on top of all that, there's that fact checker we talked about earlier.
Right, the Retrieval-Augmented Factuality Scorer, RAFS.
Exactly. Think of RAFS like another really smart friend for our detective doctor. This friend's job is to double check that the doctor's thinking makes sense based on all the clues they found. It helps make sure that the answer is based on real facts and evidence.
So how does this RAFS friend actually work? Seems pretty important to make sure the computer isn't just guessing.
Oh, it's super important for making sure RARE gets things right. So RAFS looks at all the steps the computer took to get to its answer. Then for each step, it goes back to that medical information that RARE found and checks if there's real solid evidence to support each step. Only the thought process that has the most support from the medical books is chosen as the answer.
So it's not just checking the final answer. It's checking every little step along the way to make sure it all makes sense based on the facts.
You got it. This step-by-step checking against the medical information is what makes RARE so much more reliable than a computer that might just guess or remember things incorrectly. It's all about evidence-based conclusions.
Okay, so we've got this super smart computer doctor that can find information, think hard about it, and check its work. But how is this actually being used, or how could it be used to help real doctors and patients right now?
Well, the report actually shared some really promising examples and results. One of the most exciting things is that these rare models have done incredibly well on tests that real doctors take, like those licensing exams they have to pass. And get this, they've actually been able to answer some of those really tricky medical questions even better than those big AI models like GPT-4.
Wow, beating GPT-4 in a doctor exam, that's pretty impressive.
It is. It shows you how powerful rare can be. And the report gave a specific example of a question type rare is good at. Questions that use really specialized medical terms, the kind of stuff that you really need to be up to date on to get right. And rare can do that because it always has access to the latest info.
So it can handle those really technical questions. But what about helping doctors figure out what to do to treat someone, to actually make them feel better?
That's another area where rare can help. It can actually look at all the information about a patient, their symptoms, their medical history, the latest treatment guidelines. And based on all of that, it can help suggest what the best next steps might be for treatment.
So it's like having a super smart consultant, helping the doctor make the best decisions.
Exactly. Rare's success on these really tough medical questions and its ability to suggest treatments shows that it has the potential to be a game changer for doctors who are dealing with complex medical cases.
Okay, so we've talked about how it works and what it can do.
Yeah.
But why is rare such a big deal? Like, what are the really important reasons why this could be a major step forward in medicine?
There are quite a few big advantages. As we've been talking about, rare is all about helping computers think better and more like human experts. And it does that by separating the information from the thinking skills.
And it's different from human doctors, even though human doctors have a lot of experience, because rare can access and process such a huge amount of up-to-date information super quickly.
Exactly. A doctor's experience is incredibly valuable, but rare can go through and analyze tons of medical research in a way that no human could.
And unlike some AI that just spits out an answer, rare can show you why it came up with that answer. It can actually point to the specific information it used.
Which is so important in medicine. Doctors need to understand the reasoning behind a suggestion, and rare provides that transparency, making it easier to trust.
And of course, we talked about the fact checker, so rare is less likely to just make stuff up.
Right. Reducing errors is a huge advantage when you're dealing with people's health. It's all about reliability and trustworthiness.
And it can handle those really complex cases that involve a lot of different factors and require multi-step thinking.
Yeah, exactly. Rare's ability to handle those complex cases is a major plus.
The report also mentioned that even smaller, less powerful computers can use rare effectively, which means potentially more hospitals and clinics could use this technology.
That's a really key point. Making this technology accessible to more healthcare providers is a huge deal. It could really democratize access to this kind of advanced AI.
And we talked about how rare could potentially help diagnose rare diseases much faster. That could be a game changer for people who've been struggling to get answers for a long time.
Absolutely. It could shorten that diagnostic odyssey that so many patients with rare diseases go through.
So overall, it sounds like rare is a more reliable, adaptable, and efficient way to help doctors diagnose and treat patients, all because it's constantly learning and evolving with the latest medical knowledge.
It's all about giving doctors the best possible tools and information to make the best decisions for their patients.
Now, nothing is perfect. What are some of the things we should keep in mind about rare? What are some of its limitations or things it might not be so good at?
Right. While rare is incredibly promising, it does have some limitations. One of the biggest ones is that it's heavily reliant on the quality and the up-to-dateness of the information in its library, in those databases. If that information isn't good, then rare's answers might not be good either.
So it's like if the books in the library have wrong information, then the detective doctor is going to be misled.
Yeah, exactly. Garbage in, garbage out, as they say. And as we discussed earlier, for very rare diseases, there might not be a lot of information available in those databases, which could limit rare's ability to help in those cases.
And finding the right information, asking the right questions, that can be tricky too, right?
Yeah, it's not always straightforward. Knowing how to formulate those search queries using the correct medical language, that's an art in itself.
The report also mentioned that the fact-checking part, RAFS, can add some extra time to the process. So if a doctor needs an answer right away, that could be a problem.
That's a valid point. While verifying information is crucial for accuracy, it does take a bit of extra time for the computer to go through those checks. It's all about finding the right balance between speed and accuracy.
And what about really unusual cases, new diseases that doctors haven't seen much of before? How would RARE handle those situations?
That's where RARE might struggle a bit. It's a learning system, so if it hasn't encountered something similar before, it might not have the information it needs to make an accurate assessment.
Medicine is so complex, so nuanced. Can RARE really capture all of those subtle details about how a person feels and the intricacies of their individual biology?
That's a huge challenge for any AI. While RARE can process a lot of information, it might not always fully grasp those subtle, personal aspects of a patient's experience. Human doctors still have a crucial role to play in understanding those nuances.
And then there are the practical considerations of integrating RARE into existing hospital systems, ensuring patient privacy and all of that.
Absolutely. Making sure RARE works seamlessly with current hospital systems and that patient data is kept secure and confidential are all critical factors.
And of course, you need skilled people to build and maintain these systems, which is another challenge in itself.
It is. Having the right expertise to develop and manage these RARE systems in a healthcare setting is crucial.
So it sounds like while RARE has immense potential, there are definitely some real-world hurdles to overcome. Now, let's talk about how well RARE actually performs. The report mentioned some specific numbers about its accuracy.
Yes, the results from testing are very encouraging. They found that RARE models perform very well on medical question answering tasks. In some cases, they've even outperformed some of the bigger, more well-known AI models.
Yeah, and the report had a table showing some of those results. For example, on one test with medical questions from PubMed, RARE got almost 79% of the answers right. And on another test, it was over 74%.
Those are impressive results, especially given the complexity of some of these medical questions. And as we've discussed, the fact-checking component, RAFS, really helps ensure that those answers are reliable and evidence-based.
But it's important to remember that these good scores come from controlled testing environments, not from real-world clinical settings.
Right. While the testing results are promising, we still need to see how well RARE performs when it's used by doctors with actual patients in a real hospital or clinic.
So it's done well in the lab, but we need to see how it performs in the field.
Exactly. More research in real-world settings is needed to truly assess RARE's effectiveness and impact on patient care.
Looking ahead, what do you think the future holds for RARE in medicine? Where do you see this technology going?
I think the future of RARE is bright. There's a lot of exciting research and development happening. One area of focus is improving the information retrieval process, particularly for those rare diseases where finding reliable information can be very difficult.
So making that detective doctor even better at finding those obscure clues in the vast medical library.
That's the idea. Another important area is developing AI that can handle situations where the medical information is incomplete or uncertain, which is often the case in real-world medical practice. And they're also working on improving RARE's ability to connect different pieces of information and draw inferences, making its reasoning even more sophisticated.
Making it a more flexible and intelligent thinker.
Exactly. There's also a lot of interest in combining RARE with other AI technologies to create even more powerful and versatile tools for doctors.
It's like giving that super smart computer doctor even more superpowers.
That's one way to think about it. And then there's the potential for RARE to contribute to personalized medicine, helping to develop treatments tailored to individual patients based on their unique characteristics and medical history.
And of course, as AI plays a larger role in healthcare, we have to think about the ethical implications.
Absolutely. Fairness, privacy, accountability, these are all crucial considerations as we develop and deploy AI in medicine. We need to ensure that these technologies are used responsibly and ethically.
And we need better ways to evaluate how well RARE works in real-world clinical settings.
Rigorous evaluation in real-world settings is essential to understand the true impact of RARE on patient care and doctor decision-making.
And finally, making RARE user-friendly for doctors and nurses will be critical for its widespread adoption.
Absolutely. If doctors and nurses can't easily integrate RARE into their workflows, then its potential impact will be limited. Making it intuitive and easy to use is essential.
It's been a fascinating deep dive into the world of RARE. I think the key takeaway is that this technology offers a really powerful new way to help doctors by giving them access to a vast and up-to-date body of medical knowledge and enhancing their ability to think critically and make sound decisions.
I agree. And while there are challenges to address, the potential benefits for patients in healthcare are significant.
Think about what it would mean to have a super smart, constantly learning, fact-checking assistant by your doctor's side. not just for diagnosing illnesses, but for understanding our health and making informed choices about our well-being. It raises a lot of questions about the future of healthcare and the role technology will play in our lives.
It does. It's a future filled with both tremendous promise and challenges we'll need to navigate carefully.
Well said.